Alright. Consider the quadratic function y equals x squared. The domain of this function is XCR, all real numbers. So we already know that, we are familiar with this graph. It is possible to restrict the domain of the function and thus alter the graph slightly. So if we have, let's say, f of x equals x squared, but the domain is x greater than or equal to -2, okay? So you kind of sketch the whole thing, but then, you know, you should not be taking where x is less than -2, only take where x is greater than or equal to -2, okay, because domain is restricted now. So that, notice this function with a smaller domain is a piece of the function with unrestricted domain on the left, okay. So we call this piecewise function because you take one piece of the other function, okay, another function. So let's look at this example. B, f of x equals 2x minus 3. Domain is restricted from -2 to +2, okay. So let's graph this linear function and answer the following questions. All right. So we have 2x minus 3. So -3 is the y-intercept, okay, and the slope is 2. So run 1, rise 2, run 1, rise 2, and we need to sketch it between -2 and +2, right? Look at the x values. Domain is from -2 to +2. So I did the right side, now I'm going to do the left side, okay? So we have this point, -1 and -5. Also -2 and -7. -1 and -5, -2 and -7. Okay, so when you connect those, you have this piece. And if the domain is telling you that it is, let's say, greater than or equal to, so -2 is included here, right? And it is less than or equal to 2. It is 2 is included. If that is the case, you cover those points, okay? If it says less than, if that was only less than 2, let's say, not less than or equal to, then you would put a hole here to show that that point is not included. So here it says less than or equal to 2, right? So that x equals 2 is included. But if it said this, let's say less than 2, then this is what you would do. Okay, so you would not take that point but put a hole there, saying that exactly 2 is not included, but everything else less than that is included. Yeah, but this one is less than or equal to, so we take the 2. Okay, then now we are going to evaluate f of 0. F of 0, when x is 0, y is -3. When f is 2, y is 1, right? You can also see it from here too. How about f of -5? Undefined, right? Because see, if the domain was not restricted, yes, you could definitely take -5 sub in to calculate the value of f of x. But now domain is restricted and we have only this piece. So -5 is not, x equals -5 is not in our graph, in that piece. So that's undefined. Okay, let's look at the next example. A function can be identified using several pieces where the domain is clearly defined for each piece. Okay, so let's say this time we have 2 different equations for the same function. Until now, right, all the functions that you know had only one equation. But look at this one, you have 2 equations. But that's how it goes. When x is less than 1, this is the equation that you are going to use, x squared. When x is greater than or equal to 1, you are going to use negative 2x plus 5 equation. Okay, that's how it goes. So let's sketch this here. Okay, so x squared, well, you know, if the domain was not restricted, I would start, the vertex would be 0, 0. So then step pattern is 1, 3, 5. So 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, right? That's what I would have. And same thing on the left side. But now I can only take where x is greater than 1. So I cannot take, oh, less than 1. Oh, sorry. That's true, less than 1. So then I'm going to do the other side, not this side. Thank you. So less than 1. All right. So then I'm going to take only x values that are less than 1. Okay. So now pay attention. Look at this. It is less than 1. So that 1 is not included in that piece. So what are we going to do? We're going to put a hole there. Okay. Now let's look at the next piece. Negative 2x plus 5, but that is for x greater than or equal to 1. Okay, so y-intercept is 5. So we go negative 2x. So it's going to fall to the right, right? 1 right, 2 down. Starting from here, 1 right, 2 down. 1 right, 2 down. 1 right, 2 down. And it goes. Okay. So I'm going to draw it for x greater than 1. So I'm just going to take these values here. Alright, check now the interval x greater than and equal to. So I cover this point when x is 1 for this one, for the line. Is this okay? Okay. So evaluate f of negative 2. Which equation you are going to use? Okay, so x negative 2, so x is less than 1. So you are going to use only this equation, x squared, to calculate that. So negative 2 squared is 4. Not both, okay? Don't use both equations. Okay, f of 3. 3 is greater than 1, right? So I'm going to use this second equation, negative 2x plus 5. So negative 6 plus 5, negative 1. And we already sketched the graph. Yes?
Can you restrict only the x, or can you restrict the y?
Can you restrict?
Only the x, or can you restrict the y, or can you restrict both?
No, this is given always for the x.
Only.
Okay. Okay, how to graph a piecewise function. Graph as usual, but pay close attention to the values of the function at the endpoints. Okay, so you have to take the exact values of the endpoints for sure. Always include the specific endpoints of each domain and another value or two, okay, for each piece. Note, pay close attention to the endpoints using the definition of the domain to determine whether to include color in the point at that value or exclude open or uncolored circle at the point. We already discussed that. Alright, so we have now this graph x minus 3 square when x is greater than 3, and we have 2x minus 8 when x is less than or equal to 3. Okay, so when x is greater than 3, x minus 3 vertex is 3 and 0. So let's put that 3 and 0. A value is 1, So that gives you step pattern 1, 3, 5. So 1 right, 1 up, 1 right, 3 up, 1 right, 5 up. Okay. Well, this parabola goes on the left too. However, I should only take where x is greater than 3. Okay, so I'm not going to even sketch the other side. Should I take this point? X equals 3? No, because see, look at the domain, right? X greater than 3. So I'm going to make an uncolored circle there. Or a hole. Okay, the other piece, 2x minus 8. So minus 8, y-intercept, 1 right, 2 up, 1 right, 2 up, 1 right, 2 up. And I'll go up to 3. And do the other side. Okay, here. Should I include 3? Yes. We covered. Let's look at next example. Y equals 0 when x is less than 0. So it's a horizontal line, correct? When x is less than 0. And y equals 1 when x is greater than or equal to 0. So when x is less than 0, we have y equals 0 line, which is the x-axis. Look at the domain. It is less than 0. So this point is not included. Then the other one is y equals 1 line when x is greater than or equal to 0. Y equals 1 line. So this time x is greater than or equal to, so we include this point. The last question. Determine the equation of the function f of x and the domain given the graph. This time we are doing the opposite thing. You are given the graph and we are going to write the equation of the graph. So f of x. So how many pieces, different functions we see here? 2. There's a line up to 2, correct? And there's a parabola. Okay. So when x is less than 2 and when x is greater than 2, right? So what is the equation of that line? So y-intercept is 0, slope is 1. So x only. How about the equation of that parabola? So vertex is at 4 and negative 2. So x minus 4 square minus 2. What is the step pattern? 1, 3, 5. So a is 1. Okay, should I include 2 in any of those domains? Well, this is a hole, is not covered, so I should not be included in one of them. Okay? And we are done.